Hi guys, Glader here. Today I have another video about what I've been up to lately, and I've been working a bit on GGDBF. And if you saw the last video, that's a library I'm going to use for taking SQL data modeled with Entity Framework Core and turning it into a binary flat file that supports relational data through navigation properties, but without any dependencies on any database libraries other than this one, and load them into memory for video games in Unity 3D and .NET, whatever. So to do that, I'm using a C#9 feature called source generators, and I've used this before with the binary serializer, and it's going okay. I'm prototyping it. It's a little messy. It's all over the place, but I want to show you guys basically where it's at right now. And there's also a few, like I don't know really how to start. This is such a weird video, but there's a few ways you can do source generation in C#, and I'm using source generators, which is a name of a feature that's new in C#9. And I'm also using actually a string-based approach, which I'll show you in a minute. Now let's go into the class emitter, because right now we're just emitting a class, and that's pretty much the most important aspect of it right now. There's a few ways to do it. You can generate strings, or you can use Roslyn, syntax trees and nodes to create C# code. I'm doing this approach because I wanted to try it out. The FreeCraft Core serializer, which I can pull up, uses syntax nodes, which look like this. You build a tree of nodes. It is wild. So we're trying this way this time to see if it's any easier. Great for parsing the nodes and syntax trees API, but maybe strings for generation is easier. So that's what we're doing. And so the idea is we need to create something akin to a DB context. If you're familiar with Entity Framework, we're going to create a DB context that holds all the sets of data for for the game data, so we can load it into memory and stuff, and have like a database that you can kind of query with LINQ and all that. So let's actually go a little bit over the code, which is it's a mess. Okay, it's just I'm prototyping, and then I'll refactor it later. You have to bear with me here. So when you go to actually emit this class, you provided some information. In this case, right now we only got like the name, accessibility, and some properties. By the way, first use of C# record types. I don't quite know if the automated comparison will work with like such a strange reference type. I haven't tried, so maybe it does, maybe it doesn't. But C# record types, cool, huh? Am I right? It's pretty cool. I might start using that more often because this is this one-line syntax. That's pretty nice. So when we go to admit, we generate a partial class because we've already got a partial class. And let's take a look at the class we're actually trying to look for. We're trying to look for classes that have these attributes marked on them. For example, here's a test, and they might have model types on them. And so we're going to actually generate all the code for that. And the idea is we generate all the serialization code, the code that maps from any framework object to the actual like a binary representation, and then serialize it down to a binary file, all that stuff. So that's what we're going to do. And this is what we got so far. We want to take a look and find for every property we've got, because we add some properties here. And if you want to see where we're doing that, like I said, it's kind of a mess. We're basically trying to find all the model types, which in reflection is simple. But when you're parsing a syntax, symbols and syntaxes and stuff like that, it's not so simple because the attribute doesn't really exist. You can't use reflection, so you have to use this very weird API that came with source generators in the code analysis. Now, I should say actually it was introduced for analyzers, but it uses the same API, the analysis API, because it might not even be real C#. So I don't even think you can like. You got to try to like parse it a little bit, and you're not at runtime, can't use reflections. So the API is pretty crap. In fact, I created something in Glader Essentials that really help you actually interact with this stuff because I plan to write more source generators in the future, and you know the API sucks ass. To be honest, it fucking sucks. So we need some of these extension methods for now. Maybe Microsoft, add something like them in the future. I don't know, but for now, I don't need them. I'm not going to write everything you got to write every single time you want to find stuff like this, especially because interacting, taking a type. This is a generic type, and you want to find attributes of this type. There's no concept of this in source generators because they use the symbols and uses text and everything like this. So having an API like this, I think, is very great. So I actually try to retrieve the model types, and we try to get the table name. If you're familiar with Entity Framework, you might mark these things with table attributes from data annotations namespace. Very common. People use this. You have to use this for any framework. So anyone who's used this should be familiar with these type of attributes or annotations. And when you go ahead and you add the property and you actually try to emit the source code, you're going to generate a property for each of these. And this is going to be like the DB sets. If you're familiar with DB sets from any framework, it's kind of be like the DB sets, but we need to generate them. We don't want them to be DB sets. We want them to be, well, let me show you what you want them to be. When we actually compile this, we can inspect the debug view of the source generated. You don't need to actually have these source files in your project. They're actually interleaved into the compilation step, but you have an option to spit them out for debugging purposes, which can be quite useful. So let's actually take a look at what we've generated with this crazy nonsense. And you can quite simply see not a whole lot because it's still in the very early stages of development. But we now have another partial class definition of the test context with a few properties. And these properties are basically the DB sets. You're going to access this data like it's a DB context, except it's going to be through the read-only dictionary interface. You're going to be able to provide the primary keys expected, and get stuff out. It's not just going to be a straight list of stuff. I'm only going to support stuff with primary keys, probably. Maybe there's a case where you just want to support a collection of stuff where the data is not keyed, but no, I haven't really thought much about that. And so this is basically what it's going to be like. This is going to be serialized, binary data loaded at game startup, and you're going to have access to this rich relational database with navigation properties. And I was talking about navigation properties, and I showed you some of those in the last video. But you really got to look these things up because it's very hard to describe. It's basically a property that references another table like a foreign key, but in the C# type, which is great. And we really, really want those. Trust me, when I was writing GLAD MMO for the World of Warcraft Unity 3D client emulator, and haven't seen that, it's probably the best thing I've ever made. Rip, sorry that it's canceled, but it was the best thing I ever made. And I realized having to take okay, maybe test model references test model type 2, and you want to look it up. Well, you've got like a foreign key in there, and then you just have like the string ID of test model type 2, and that kind of sucks. Wouldn't it be nice if you could just, write, test data, index it for the key, and then actually get the property of the foreign key reference to test data too? Well, that's the whole idea, and that's what we're going to get, and that's what any framework provides. But to get that in memory without any dependencies on any database or engine frameworks, and in fact, you won't even need a dependency on GGDBF, this compiler. You just have these attributes. You'll just have some annotations, and all the code will be generated to load this up at startup, and you'll be able to access it and stuff like that. And there'll also be code generated to convert the SQL database into these expected formats so you can load them into memory and stuff like that. So yeah, that's where we're at right now. Very early stages, but it's starting to take shape now. We're starting to generate compilable code, which is cool. C# source generators are a nightmare to work with, absolute nightmare. But for many reasons, one of them is the setup that you have to do for the CS proj is absolutely insane. There's no button to press for this. There's no document. There's basically no documentation for this. Absolutely insane. I don't know what Microsoft is smoking, thinking that this is a good way to provide a feature to developers, but that's a whole other story. I could rant about this all day. But yeah, that's pretty much it. Um, just need to support more of those features that I just talked about, and then it'll be kind of ready. It's going to be tough, but I think this will provide a very important, very rich way to handle relational game data in games, sort of like World of Warcraft did with DBCs in a relational way. And I'm really excited about this, and I think that once I finish this, every project I work on from now on is going to take advantage of this awesome way to do data in SQL for games and then export it to binary, but still have that relational data, which is super super awesome. So thanks for watching, guys. Sorry it was a real technical video. I'll see you in the next one.